We're now going to take a look at the difference between protected access and package access with respect to members of a class. Recall that the members of a class can be given modifiers that specify how we can access it. So we have public, private, and protected. But what if we don't use any of those? What if we just create a variable or create a method without either public, private, or protected? Well, if we do this, then Java is going to give that member the default package access. So what is the package access? What exactly is that? Well, what this means is the member can be directly accessed by any class that's contained in that package, even if the class is very different from what the current class does. What we're saying here is if we don't specify public, private, or protected, then that particular member can be directly accessed by any class within the same package. There is a difference between package access and protected access, and it's going to come down to how subclasses are applied to this. So just as a reminder, if a member has package access, it can be directly accessed in any class in that same package. So another way we can phrase that is if a member has package access, it cannot be directly accessed in any class that isn't contained in that package. This does include subclasses. This does include a subclass that's derived from a class containing the member if the subclass isn't contained in that package. So what we're saying here is if the subclass is not part of the package, it cannot directly access this particular member. Now, what if the member has protected access? Well, that means that member can be directly accessed in any subclass, even if that subclass is contained somewhere else. Okay? So the big difference here is if the member has package access, it can only be directly accessed among classes in that same package. If there is a subclass of one of these classes and it's not part of the package, then we can't directly access this member. Now, if the member has protected access, what we're saying here is that any subclass, whether it's in the package or not, can directly access that member. We're now going to take a look at a very specific class, which is what's called the object class. Recall that when we created our clock class, we actually redefined the toString method. And if you remember how that method worked, initially, whenever we printed the object name, we would print the name of the class and then the hash code. So we would redefine it. That way we can print whatever we actually want to print, not the name of the class and the hash code. But if this is a method that's given to us, if it's predefined, then that means it has to be defined somewhere. It has to come from some other class, right? Well, specifically, the toString method comes from the object class. So in Java, what happens is if you define a class and you do not use the reserved word extends to derive it from some other existing class, then the class that you defined is automatically derived from the object class. In other words, every class that you create inherits the object class. So another way we can think of this is the object class is the superclass of every single Java class. Let's take a look at a very quick example using our clock class. So here's how we would normally start up the definition of the clock class. You would say public class clock, and we don't include the word extends because we're not explicitly saying that we're inheriting things from some other superclass. Now here's the same definition, except now we include extends object at the end of our class header. So what this is saying is we do want to inherit everything from the object class. Both of these definitions are equivalent because as we just said, if we do not include the word extends, we're automatically inheriting everything from the object class. So if we don't include the word extends, it's as if we were actually saying extends object. So what we're saying here is that every class inherits all the methods from the object class. So what this means is that every public member of the object class can be overwritten, just like we did with the toString method. There are other methods that are involved with the object class, so we can override those as well. It also means that we can invoke any of these object methods by every object of any class type. We'll now take a look at some of the constructors and methods that are available to us from the object class. This is not an extensive list, but it gives us some of the more common things that we can actually use from the object class. So the first thing we'll look at is the constructor. So the constructor is just simply public and then object. Since the name of the object class is called object, it's going to be called object. And this is just simply the default constructor. The next method we'll take a look at is the toString method, and this is the one that we're more familiar with than anything else. So this is just simply going to be public, string, and toString. And all this method does is it returns a string to describe the object. We already mentioned by default it would be the name of the class and then an @ symbol and some hash code, but we can rewrite this as we want to. So this is going to give us some string that describes whatever object we want here. And this would be the string that's printed whenever we pass the object name as an argument in the print method. So if we have system.out.println and then in the parentheses we put the name of the object, this would be the string that would actually be printed. And just about every class overrides this method. That way it can print exactly what it wants. So a lot of the pre-made Java classes already override the toString method. And as we've done before in our own classes, we would override the toString method to have it print exactly what we want it to print. The next method from the object class we're going to take a look at is the equals method. And the syntax for this is public boolean equals, and then the parameter is some object. So we see here this is going to return true or false. And what this method essentially does is it checks to see if two objects are the same. Now we got to be careful with what we mean by two objects being the same. Usually we would say that do they have the same data members, but this is not the case for this equals method. It actually returns true if the invoking object and the obj parameter have the exact same memory address, and it returns false if the two memory addresses are different. So we're not checking to see if these two objects have the same data. We're checking to see if they point to the same memory address. What we're really checking here is if the two objects are aliases. So what we mean by an alias is that I can have an object and then maybe I don't like that name for whatever reason. Maybe we want to use a different name but have it point to the same data in our memory. So that second name would be an alias here. So that's all we're checking here. We're checking to see if the two objects point to the exact same memory address. Now, technically, if they point to the same address, they do have the same data, but we're really just checking if they have the same address, not necessarily the same data. Usually, this method is overwritten in other classes. The next method is a little bit different, at least the name is a little different, but we have used this before. This is called the clone method, and the format for this would be protected object clone. So notice that it's protected. It's not public or private. And it's okay if we're dealing with a protected method here. But what this method does is it creates a copy of the object, and then it returns a reference to the copy. We have done an example of this in our clock class, where we would create an object of the clock class and be a brand new object. We would store the values of the current object into this new object, and then we would return the address of that new object. So we have done a method like that, and that's pretty much the clone method is what we're doing here. The last method from the object class we'll take a look at is the finalize method. I think we talked a little bit about this in CS121, but we didn't do too much with it, and we're not really going to do too much with it here either, because as we're going to see, there's not a whole lot we can do with it. The way this would be show up in our object class is it would be protected, void, finalized. So it doesn't return anything. And all this method does is it gets invoked whenever the object goes out of scope. This is where we would clean up several things. It would take care of deallocating the memory for an object. It's just kind of this cleanup method for us. And we usually don't override this method. We can if you want to add some stuff to it, but it's usually not necessary because this is just cleaning up the object of the class. We're now going to briefly take a look at what are called the Java stream classes. If you remember, we used the scanner class for handling inputting data from our standard input device. So usually that's the keyboard. And we've used a couple of other classes such as the file reader and print writer classes whenever we wanted to do file I/O operations. So what we have is we have these set of classes that allow us to handle input and output, whether it's through the console, whether it's through files, but we have additional classes as well. And these are what we call stream classes. Well, in Java, these stream classes are actually implemented using an inheritance mechanism. So what we're going to see in just a little bit is that some of these classes actually inherit from other classes. Here's a very simple example of how these stream classes are set up in our hierarchy. So what we see here is everything does eventually inherit from the object class, but specifically the scanner class, and then we have two other classes called the reader class and the writer class. These are all derived from the object class. So scanner, reader, and writer are subclasses of the object class. Now I'm pretty sure you haven't done anything with reader or writer before, but we're not too worried about it. You've actually used subclasses of the reader and writer class. So what we see here is there's another class called input stream reader, and that is derived from the reader class. But then the file reader class, which is the one that you have used for file I/O, that is actually derived from the input stream reader class. So what we're seeing here is all the methods that are available in the file reader class, they've all come from the input stream reader class, and then the reader class, and then the object class. So all those methods are being added to the file reader class. Likewise, we see that the print writer class is derived from the writer class. So all of the methods from the writer class are automatically given to the print writer class, along with any additional methods that the print writer class would have.